Okay, well, hello everybody. My name is Patrick Kalani. I'm with Audinate. And what we're going to talk about here is some of the principles that you're going to use if you wanted to design a Dante system to work with ST2110. So kind of what I want to start with is a little bit of just an idea, like why would you choose a Dante system to begin with? How do these things work together? What was Audinate's thought process when we started implementing the open standards? So let's start with that. Generally in the market, a lot of people know there are an awful lot of Dante products out there. Probably our nearest competitor is probably CobraNet, which isn't even around anymore, but I'm pretty sure Ravenna is probably going to catch up to them here this year. As you start looking at different protocols, you'll start to see that AES67 certainly has a large presence. There's a consultant named Roland Hemming that goes out and does how many devices are on different platforms. One of the interesting things that he finds is that, most of those AES67 devices are actually getting there through the Dante chipset. Now I bring this up because one of the interesting things about Dante is every Dante device will behave the same. Right? They all get the same firmware, they're all going to have the same capabilities. So when you start getting into behaviors and things like that, if you know one Dante device, you know them all. And so we implemented standards according to the ST2110 suite for timing, for redundancy, for RTP transport, and all of that. And that's what we're going to go through today. So as we started putting this together, sometimes people look at us and they say, why wouldn't I just do the entire network with ST2110? Why would I put Dante in it at all? And generally what I just say is, if all you have is a hammer, then every problem starts looking like nails. If you can bring a toolbox to the solution, now you can start to use the right tool for the job. And I'll just give you a historical perspective on that. Some of you may have seen me talk about this before, but 20 years ago, you'd probably remember the battles between CobraNet and EtherSound. But really, if you start thinking about it, CobraNet had a network design where you could use standard switches just like we do today. Their problem was high latency. When it first came out, it was 5 1/3 milliseconds per link. Now that was all working on 100 megabit networks. There's, all sorts of reasons for it. But when EtherSound decided to come around and start making their solution, they decided we can get that lower latency by avoiding the network at all. So they gave you the lower latency. The only problem was you had to daisy chain everything together. And so while we think of these as being competitors, if you really step back, you realize each one of these had a strength and a weakness. And if you look at the application that this network was going to serve, you would probably know what solution was going to win, regardless of how hard that sales rep worked at it. When you were looking at tours back in the day, 20 years ago, EtherSound and CobraNet were often used on the same project. So EtherSound would get stuff from the stage to the front of house. The artist would have a very low latency experience. When you had to hit the PA system or a distributed audio system, that was a CobraNet. They were used in the same project at the same time. And that's kind of how we saw ST2110 and Dante. They were going to be different standards working together. So where all this really began was there was a study that AES did, it's probably 12 years ago now. It was called the Best Practices for Audio Networks. And they looked at a lot of the common networks that were available at the time, and they said, all of these are sending uncompressed audio. The data that everybody is transporting should be completely compatible. But the difference is in how you package it, how you ship it across the network. So out of that, they said, we could make a lot of these compatible if we developed some new solution. And that's where AES67 really kind of came from. So when AES67 was first announced, it was basically, we can read this thing where AES67 enables interoperability between networking solutions currently available, such as Dante, Livewire, QLAN, Ravenna, WheatNet IP. But their point was that AES67 was not a new technology. It was a bridging compliance mode. You could take a system that you have, maybe you have a system at a stadium that's all built on Dante. Then you have a broadcast truck that's going to pull up. That could be anything. That could be a Livewire truck if it's radio or Ravenna or whatever. And in order to connect those, generally what we did is something like analog AES3 MADI, right? Something like that. Well, now AES67 and ST2110 are solutions that could fall into that space. Any of the network solutions available out there on the market today have far more capability and far more integration in between products. So AES67 is a good way to get between them. One of the ways that I have explained this before is if you think about word processors back in the day, if I had Microsoft Word, I was sending a document to somebody else that had Microsoft Word, I would send them a Microsoft Word document. If I had Microsoft Word and they had something else, I might send them a text file, an RTF, something like that. So AES67 and ST2110 are really meant to be ways in the audio world of connecting teams together. And this is just a quote from Yamaha where they were saying they were largely known for format neutrality. And their products, they would be able to pop in these cards for different systems and instantly have connectivity anywhere you wanted. Now the thing that they said was, they had 30-some cards. It's not a profit center. These cards were simply made to enable their other products to connect to your systems. Now, by using something like AES67 or ST2110, you don't need an option card anymore. The built-in Dante port could do it for them. And so, if you think about it, AES67 and ST2110 don't replace Dante. They replace your SDI, embed, de-embed devices, MADI, AES3, and analog links. And generally how you kind of look at this in the production workflow is anytime you get closer to the sound stage, anytime you're getting closer to capture, that might be more likely to be an environment like a Dante system. The video production team could very well be using 2110. Great, we can produce on Dante, send them a 2110 stream, we're compatible, and you go down into the conformance and the turnaround and the branding facilities, that can all be 2110 as well. So it's just kind of a structure on where you're going to be able to find these things and where we saw that being appropriate. So when you're designing a system, some of the things you have to understand from a Dante perspective are, first of all, which mode do you want to use, AES67 or 2110, and do you want a managed or an unmanaged Dante system? So one of the things that we point out is that AES67 and ST2110 are compatible formats. As a matter of fact, you could put AES67 out of a Dante device, receive it on a device that's configured for 2110. The difference for us is when these solutions were released. So AES67 mode was released in 2015. And the expectations back then were for a very simple system, and we want to be able to do something ad hoc. We just want to do something very quickly. You don't have access to every parameter under the sun. We just said, if you just want to throw something together quick, set them this way and it'll work. Once 2110 came along, we started giving you access to a lot more parameters. But with power comes responsibility. Now you're going to have to know how to make all those settings. So let's talk about the AES67 solution here. So like I said, this was something you could imagine a radio station had a talk show or something like that. A band was on tour and they wanted to promote their local concerts or their latest album or something like that. So they come into the studio, they've got a Dante system that they're using, and they could just make that connection very quickly with AES67. That was the vision for how this would work. If you needed to get things back and forth, you can see there's a stream in blue on our system. That's an AES67 stream or a 2110 stream. That's how we show them. And in order to create one, all we have to do is double click and say, give me an AES67 stream. You can determine your multicast address and we send it out there, no problem. So that's how we put all that together. And it was at this convention in 2015 that we did our original public demonstration. This was actually during the setup. Then later on, we cleaned it all up, right? So during that demonstration, we showed Dante, Ravenna, QLAN, and Livewire all working together. The following year, if you're looking for sort of a tutorial on how this mode works, I got together with a lot of those same people and we made a video that walked step by step through the process of creating links between all of our different platforms. So that's a good link to go to. So that's a little bit about AES67. Like I said, designed to be ad hoc, very simple. But once we start talking about ST2110, now we're talking about a project a couple years later where people were trying to take on much bigger tasks. And you can start to see workgroup photos like this, where everybody was doing the dirty hands events. And the goal was to be able to do facilities where they were doing turnaround facilities or major video production. So instantly we looked at that and we said, you're not looking for ad hoc connections anymore, you're looking for something more in-depth. Now, if you want the full step-by-step on how to make all these connections, we have a video for that we came out with in 2020. So this was a webinar that we put on. And again, if you download this, I've got the link in here. With a link directly to the demonstration, step-by-step, it'll show you how to get through it. But so, like I said, the first thing you have to think about when you're deciding to use Dante on a network with open standards is, do I want to do the ad hoc AES67, or do I want to do the full control ST2110 mode? Now, as we started introducing these things, some people had some misconceptions. Some of it comes right out of our Dante certification training, because that was really designed to teach people Dante. Once we're in the open standards modes, things are a little bit different. So let me talk about some of these. So the first thing is about Precision Time Protocol. So Precision Time Protocol version 1 came out in 2002. Dante went public in 2006. So obviously, Dante uses Precision Time Protocol version 1 by default. Precision Time Protocol version 2 came out in 2008, and then all of your open standards followed that. Obviously, all of them use PTP version 2. So the question comes up, can Dante use Precision Time Protocol version 2? And the answer is yes, we can use Precision Time Protocol 1 and 2 at the same time. And here's basically how it goes. So if we have a Dante system out of the box, we put everything on the network, they automatically elect a clock leader, and everything is synced by PTP version 1. Now, if you go through and you change some of those devices to work in 2110 mode, you will be able to follow an external clock that is now running PTP version 2. So that's going to feed all these devices, and this is what we call a clocking domain. So all of these are working together, right? One person is saying, here's what time it is, all the other devices are following that. Now, if you still have some older devices that do not support ST2110, then what we can do is elect one of those devices to be a boundary clock. And he says, okay, I see what time it is from the primary leader. Now I'm going to go ahead and distribute that time to other devices using PTP version 1. And down the chain it goes. So that's basically how this thing comes together. When we did this video, I actually show Precision Time Protocol 1 and 2 working together. We opened up PTP track count, something you're probably all familiar with, and we show exactly what it looks like. We show the two different clock leaders, then we make it all follow the one, and you can see how that comes together. Now, the other thing to think about, and again, this comes straight out of Dante certification training, we mentioned that Dante has certain DSCP markings. So clocking follows marking 56, the AV media follows 46, but AES67 had different marking values. And so how does that work? I remember having a conversation where we were talking about this, and you know, AES67 was a little bit loose with how they were going to implement things. I think when we got around to ST2110, things were enforced a little bit more. And I actually made a joke. I'm like, so, you know, what do? Do they go around to all the engineering teams, send a nun down there with a yardstick, and every time somebody starts typing something wrong, whack? Pretty much is what we were told. So in 2019, when we released our ST2110 firmware, we flipped the open standards DSCP markings so they would follow the AES67 markings. So they are completely in alignment, and that's how we have devices that are JTNM tested. You'll see they pass those certifications.
The 3.1.
Okay, so the last thing is just an idea on how you're going to take these devices and organize them. So obviously you can do something where you just say, I'm going to take all the devices, throw them willy-nilly on the same network, and make them all work together. We can absolutely do that. As I said, the JT&M testing certified that. Another option is to say, I'm going to take my Dante devices, put them on a VLAN, and I'm going to take the ST2110 devices, put them on a different VLAN, and I'll just route them together. This gives me more flexibility in how I want to optimize the network for each individual system. And then another option you can do is a similar idea, but maybe instead of using a router, you actually use a bridge device. So one Dante port receives something in, the other Dante port repeats it onto the 2110 network, and you can configure those completely differently if you want. So it just depends on how much isolation you want. In something where you're putting everybody on the same network, you're definitely going to be in 2110 mode for this. And that means you're going to need to have Dante Domain Manager. Now what that does is that's a central server that will look at all of our devices, and anytime you have settings to make, we populate it across all of our devices directly. If you're going to have QoS settings, if you want to have some precision time protocol version 1 on the network, this is the DSCP queue. I would just merge that with your AES67 PTP down at 46, put it in the same queue. If you want to say, I don't want to use PTP version 1 at all, we can disable that. A lot of people didn't know that. But if we look in Dante Domain Manager, here's this screen where we say, here's our SMPTE timing settings. Right here is one that says PT version 1 multicast. You just turn that off. Now everything is PTP version 2. You don't have to worry about anything at all. So that's something that has solved some issues for people. Now, once you decide, like, hey, maybe I want to put Dante on a separate network, it's going to be a fairly large system, it's a very big content creation network. Okay, you might still be using Dante Domain Manager in there, but like I said, doing separate VLANs means you can optimize each VLAN for each type of traffic. And if we're going to use a lot of Dante devices that don't have ST2110 support, this would be what I would suggest. Okay, because you're going to be using PTP1 to get those things synced in. And by the way, some people ask, well, like, what would be an example of something you might use that doesn't have ST2110 support? Dante Virtual Sound Card would be a good example. And by the way, we actually have a version of Dante Virtual Sound Card for broadcasters, where broadcasters have the need to be able to spin up a virtual server, and then they need to be able to send things out. They're going to tear it down and they're going to rebuild something completely different the next day. One of the frustrations was Dante Virtual Sound Card had a license that tied to the installation. So every time you bring down the virtual machine, you had to buy it again. We've updated it so that you can buy a separate license that ties to Dante Domain Manager. And now you can respin those virtual machines all day long and it's going to be just fine. And finally, like I said, you could do the bridge networks like this. Now you have total isolation. This is very easy for devices, like I said, that don't have 2110 support, so they can run PTP1 if you want. Some people just get nervous. They say, you know, it's a production where they're constantly changing the network configuration. And the other nice thing about having a bridge device, you can still do routed networks if you want, but the bridge device can also do sample rate conversion for you in this instance. So there are sound stages that are running at 96K, and your station is going to run at 48K, so you need to be able to convert that down. Structurally, basically it's just two different ports going to different devices. The only processing in between is sample rate conversion, if desired. Another way to do this sometimes is to have a device like your production mixer. You know, it's already connected with a network interface to the Dante network. You just pop in an option card and you can feed it to the other system. So it doesn't have to be a completely separate piece of hardware. And as a matter of fact, that's how several large stages are being done today. So here's an example, the Royal Albert Hall. They actually have a PA system in there that's 384 speakers, I believe. They did a fully immersive sound experience in there. When touring bands come in, they don't want to give people access to all 384 settings and all of the DSP that goes with it. So all of that is locked down. They just give them one port and they say, feed us the channels here. I think they have up to 16 channels. The rest is handled in the spatial processing. Getting back to the broadcast side, the BBC Broadcasting House Studio 80 had a refurb where they put in an SSL System T, I think it was. And this is just an example where they were able to make it go there. Some of you are probably also familiar with the installation that was done at the NFL facility in Los Angeles. They even say on here, we actually had two different types of precision time protocol, one running the Dante network, one running the 2110 network. Gee, I wonder what those two types of PTP could be. And they lived on the same switch. They've worked very well together. But like I said, those are three different options you can consider when you're designing the system. How much separation do you want? How much do you want things to merge together? So I guess in summary, like I said, the Dante products are fairly ubiquitous. AES67 and 2110 modes will work very consistently across all of them. You just choose which one you want to go into. When you're using AES67 and 2110, think of them like a format converter going to the next system. So it's kind of a replacement for MADI, AES3, and SDI. The two modes that we present are really representative of the eras we released them in. We're not trying to say AES67 and 2110 are different worlds. We know they work together, and our two modes do work together. It's just a matter of how do you want to work with it. Dante supports PTP1 and PTP2. You can use them, you can use one, you can use the other, you can use them simultaneously, do whatever you like. When we get to the QoS markings, Dante does respect the AES67 QoS markings for PTP2 and RTP. And then when you're designing systems, just think about that topology. Do you want to put everything on the same network, routed network, fully bridge it, and create a separation? And that is it. Just for the video, I'll put the links up there. I'll just flash through them. There you go. It's like when you get to the movie, you got to roll the credits really fast, right?